Hi everyone, Ravi this side. Welcome to Engineering Adda. Today in this video, we are going to discuss about the lead code array question, which is question number 704, and it is a question on binary search. So how we can perform the binary search on a array, that is what we are going to discuss here. That is what we are going to solve here. So let me try to go to the lead code and go to this particular question number 704. So we are on the lead code and we are on the question number 704. If you don't find this question, what you can do is you can go to this lead code under the tag array, and then there you will find the question related to the arrays, and you can go to the question number 704 and you will get this question there. So go down and here you can see you go up. Okay, so I don't think it is coming under the lead under the array question, but yeah, it is one of the array question. So you have to go to this question number 704. How you can go, let me try to show you. So if you go up, what you can do is you can directly go to this lead code questions, and you can go to the problems, and not sure under which section it is coming up, but here you can see under the problems, under the binary search, you can find this question. So where we have to go is we have to go to the binary search. So let me expand this one and let's say go to the binary search. I was thinking it is under the under this array question, but yeah, it is under the binary search, and you can go to the question number 704 now. So you can see it's 704. Now go to this question, and it is under the EG section of this lead code. So we are going to solve this out. So what we have to do is we are given an array of integers. Let's say its name is nums, which is sorted in ascending order. So we have a sorted array which is sorted in ascending order, and an integer target. Write a function to search the target in nums. If the target exists, then return the index of that. Otherwise, return -1. So it's a very simple question that you have to solve. You have to apply a binary search to find out a target in the ascending order array. If the target exists, you have to return the index of that target. Otherwise, you have to return -1. You must write a algorithm with order of log n runtime complexity. So we are not going to, you should be writing the algorithm in such a way that its complexity, its time complexity is order of log n, not order of n and other things, right? You have to write at least order of log n. So that is what we are going to discuss here. So here you can see, for the example, first we are having a array with -1, 0, 3, 5, 9 and 12 as the element inside it, which are arranged in the ascending order, and the target is 9. And if you'll find out the 9 inside this array, you'll find that 9 is there and its index is 4. So we have to return the 4 here. 9 exists in the nums and its index is 4. That is why the answer is, or the output is 4. Now for the example 2, you can see that we have the nums array where we have -1, 0, 3, 5, 9 and 12, and the target is 2, but we don't have the 2 inside this array. So what we are going to do is we are going to return -1. Okay, so this is what we are going to solve here, but make sure the code that you are writing is having the time complexity of order of log n. Okay, so let's get started for that, and let me try to write the code for it. So before going to write, let me try to show you how we are going to write the code which is giving us the time complexity as order of log n. So if we'll go here, you can see that okay, let me try to go to the notepad. I already have one example here. So let's say we are having this array which is 1, 2, 3, 4, 5, 6, 7, 8 and 9, and you can see that it is arranged in the ascending order. Now let's say the target is 7. Okay, so how we can find it out, this target, with the help of order of log n complexity algorithm. So there is a, like, if you're going to find out this target inside this array, you can simply have a for loop, and then inside that you can search it out, but that will give you the complexity of order of n, not order of log n. So here, to find out the algorithm which give us the complexity as order of log n, then what we have to do is we have to try to narrow down the search. Okay, so let's say what we are going to do is we are going to find out where this target should exist. So to find out this target where it should exist, what we are going to do is we are going to divide this whole array under 2 sections, and we are going to find out under which section this target should exist. So we are going to divide this array in 2 parts, and we are going to find out the middle element. If the middle element is, let's say, less than the target, then the target should exist in the right part. If the middle element is right, greater than the target, then target should lies in the left part. That is what we are going to follow here. So in this way, what it will do is it will try to reduce the complexity. Like any case, we have to search on one of the part of the array, not the whole array. Okay, and that will give us the order of log n complexity. Okay, so that is what we are going to do. So how we can achieve it out? So first thing that you have to do is you have to keep 2 pointers. Okay, so the first pointer is let's say low, and the second pointer is, let's say, high. So we are going to keep 2 pointers, high and low. Okay, so what we are going to store in the low is we are going to store the starting index of this array, which would be, let's say, 0, and here in the high we are going to store the maximum index of this array. So maximum index would be array length minus 1, right? So it should be like array dot length minus 1. So here what it should be like, if you'll start looking for the length of the array, it is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So our maximum, or you can say the high pointer, would be 8. Okay, if you'll start looking at this array with the 0 indexing, so it would be like 0, 1, 2, 3, 4, 5, 6, 7 and 8, right? So that is what the high index is, it is 8, and the low index is 0. Now we are going to find out the mid index. So how we can find out? The mid index would be low plus high divided by 2, right? So we are going to keep this in bracket. So low plus high divided by 2 will give us the middle index. So in this case it would be 4, right? 0 plus 8 divided by 2 equal to 4. So the middle index is 4. So now let's see what element we have in the middle index. So it is 0, 1, 2, 3, 4. So the middle index is 4, and the element at that index is 5, which is less than the target, right? So in that case, what we have to do is we have to focus on this part. Okay, so in that case, what we are going to do is we are going to shift our low to mid plus 1, which is coming here at like 5. Index would be 5, and the high would be the same. And now we have to find out the mid between them. So that is what we are going to do, and that is where we are going to write the algorithm for. So we are going to use the while loop, and we are going to iterate through the while loop, keeping the condition in mind that low is less than or equal to the high. So whenever the low is less than or equal to the high, we are going to iterate through the low. If low is becoming greater than the high, then we are not going to iterate through the loops. That is what the condition is, and this is how we are going to find out the target. So let me try to go to the lead code and try writing the code for you so that you can get better understanding of it. So the first thing is let me try to initialize this 2 index. Let's say low is 0 and int high equal to arr dot length minus 1. Okay, now we have the low and high. Now what we are going to do is we are going to keep a while loop, which is if low is less than equal to high, then we are going to iterate through the loop. If not the case, we are coming out of the loop. Okay. Now what we are going to do is here we are going to look for the mid. Okay, so let's say if AR mid double equal to target, so then we have to return the target index, okay, which would be the mid here, right? Before that, what we have to do is we have to calculate the mid. So how we are going to calculate the mid is let me try to calculate it out. So it's, let's say, int mid equal to low plus high. Let me keep this in bracket, low plus high divided by 2, which is, this is the mid for us. And now what we are doing is we are finding out if that mid index does have the target at that mid index. If that is the case, we are going to return that mid index as the result. Otherwise, what we are going to do is we are going to look for the right or the left part. Okay, so for that, let's say else if ARR mid is, let's say, or you can say target is greater than the mid. So what we can show is target is greater than the mid. In that case, what we have to do is we have to look for the right part of the array. Okay, so in that case, what we are going to do is we are going to assign low as mid plus 1. Okay, and the high would be the same. Else what we are going to do is we are going to look for the left part of the array, which would be, in that case, we have to update the high. So high would be mid minus 1. Okay, and this is how we can solve this out. So we are good now. Now let me try to put the last condition. If we are not able to find any target element inside this array, then what we have to do is we have to return the minus 1. So we just have to return minus 1 here. So let me try to again brief you. What we are doing here is we are finding out, we are just keeping 2 pointers, low and high, to have the track of low and the high index of the array. Now what we are doing is we are creating a loop where we are looking for low is less than equal to the high. Then we are searching inside that array. How we are searching inside that array is we are dividing that array into the 2 parts. Based upon the mid, we are searching that element inside that array. So if we are finding out the target at the mid, then we are returning the mid. Else we are looking for the if target is greater than the mid, then we are looking for the right side of the array. Otherwise, we are looking for the left side of the array. That is what we are doing. And if the target does not exist into the array, then we are returning minus 1. Okay, so we are good now. Let me try to run this code and then see how it is behaving. So you can see it accepted both the test cases. Now let me try to submit it. And here you can see it beats 100% of the solution. And it took only 0 milliseconds. And if you go to this analyze complexity, okay, upgrade to analyze more. Okay, I don't have the subscription, but at your side, you can go to this analyze complexity and you'll find that the complexity of this solution is order of log n. So this is how you can solve this binary search. Okay, so this is about the video, guys. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.